This week, I'll show you how to train the Naïve-based classifier. In this context, we train in something different than in logistic regression or deep learning. There is no gradient descent. We're just counting frequencies of words in a corpus. You'll now be creating, step by step, a Naïve-based model for sentiment analysis using a corpus of tweets that you've already collected. That's awesome. The first step for any supervised machine learning project is to gather the data to train and test your model. For sentiment analysis of tweets, this step involves getting a corpus of tweets and dividing it into two groups, positive and negative tweets. The next step is fundamental to your model's success. The pre-processing step, as described in the previous module, consists of 5 smaller steps. 1. Lowercase the text. 2. Remove punctuation, URLs, and handles. 3. Remove stop words. 4. Stemming or reducing words to their common stem. And 5. Finally, tokenizing or splitting your document into single words or tokens. For the assignments in this week, it will be relatively straightforward to implement this processing pipeline. But in the real world, you might find the gathering and processing of text takes up a big chunk of your project's hours. Once you have a clean corpus of processed tweets, you'll start by computing the vocabulary for each word in class, like you did in the previous week. This process will produce a table like the one shown here. You can compute the sum of words and class in each corpus in this same step. From this table of frequencies, you get the conditional probability, or probability of word given class, by using the Laplacian smoothing formula. See how the number of unique words in V class is equal to 6. You only account for the words in the table, not the total number of words in the original corpus. This produces a table of conditional probabilities for each word in each class. This table only contains values greater than 0. For the fourth step, you'll get the lambda score for each word, which is the log of the ratio of your conditional probabilities. The fifth step is the estimation of the log prior. To do this, you'll need to count the number of positive and negative tweets, and then the log prior is the log of the ratio of the number of positive tweets over the number of negative tweets. In the upcoming assignment, you'll be working with a balanced dataset, so the log prior is equal to 0. But for unbalanced datasets, this term will become important. In summary, training a Naïve-based model can be divided into 6 logical steps. You get or annotate a dataset with positive and negative tweets. Typically, it's better if your tweets match the same context that you want to use in the final model. Then you process the raw text to get a corpus of clean, standardized tokens. You compute the dictionary of frequencies for each word in class, then compute the conditional probabilities of each word using the Laplacian smoothing formula. You compute the lambda factor for each word, and finally, you estimate the log prior of the model, or how likely it is to see a positive tweet in your account. Wow, that was quite a lot. Now, you have seen how to build the probability table needed to apply Naïve Bayes. The next exciting thing we'll do is to classify your sentences.